This is Math 139, Section 4.2. We're going to be looking at operations on rational expressions, or how to add, subtract, multiply, and divide algebraic fractions. We'll begin with multiplication and division. Remember what you do when you multiply or divide numerical fractions. If I wanted to multiply these, I might start by looking to see where I have common factors. For example, I might notice that both the 8 and the 12 are divisible by 4. 8 is 4 times 2, and 12 is 4 times 3. And then we say 4 divided by 4 is 1. Next, I might notice that 5 and 25 are both divisible by 5. 5 is 5 times 1, and 25 is 5 times 5. And then I can say 5 divided by 5 is also 1. So I end up with a product of 3 on the top and 2 times 5, or 10, on the bottom. Now again, you probably don't write all of that out anymore for numerical fractions. You don't need to, because you're able to see the arithmetic more easily. But notice what I'm really working with. Again, I've gotten factored forms of all of my numbers. And then once I have the factored forms, I can see where I can reduce to a fraction of 1. Division is very, very similar. The only difference is, to start a division problem, you have to take the reciprocal, or invert, the second fraction and change to multiplication. So, to divide by 21/20ths, I multiply by the reciprocal, 20 over 21. After that, it works the same way as this one. For the 14 and the 21, you probably notice a common factor of 7. 7 times 2 and 7 times 3. Or 7 divided by 7 gives you 1. And for 15 and 20, you probably noticed a common factor of 5. 5 times 4 and 5 times 3. And then 5 divided by 5 gives you 1. So we end up with 2 times 4, or 8, on the top, and 3 times 3, or 9, on the bottom. We're going to be using these same methods for multiplying and dividing algebraic fractions. We'll always want to work with factored forms so that we know when we can divide and get that factor of 1. And if we do have division, we'll remember to multiply by the reciprocal. So here are some examples with algebraic fractions. Let's start by getting all of the factored forms. 20x to the 6th is a monomial, no factoring required. And in the denominator, I could factor out a 7, making that x minus 2. Second fraction, I can start by factoring out a 2, which gives me x minus 2. And the denominator, again, is a monomial, so I can't factor that. Now that everything's factored, everything's multipliers, I can say x minus 2 divided by x minus 2 is 1. I can also do a bit more. I could say x to the 6th divided by x squared, if I subtract those exponents, is going to leave me x to the 4th. And then finally, 20 over 50, I could divide both of those by 10. Would make that a 2 and make that a 5. So, when all is said and done, on the top, 2 times 2 times 1 is 4, and I still have that x to the 4th. On the bottom, 7 times 5 is 35, and everything else has already been divided out. So I'm done. All right, let's take a look at number 2. This is division, so I'm going to start by just rewriting it as multiply by the reciprocal. All right, I've got a bunch of factoring to do this time. In my numerator, I could take out a GCF of 3, which makes that 2x plus 5. And in the denominator, that's a difference of squares. Let's see, 9 is 3 times 3. And the minus x squared would be a plus x times a minus x. So 3 plus x times 3 minus x. Let's see, second numerator, I can take out an x. Makes that x minus 3. And then it looks like I am going to need a little scrap paper down here. I've got this more complicated trinomial. The leading coefficient's not 1, so it's going to take me a little extra work. I'm going to need a sum of 4 and a product of negative 60. So let's see, how about 6 and 10? If I make these 6 negative, those will add up to a positive 4. So I think that's going to work. And we'll split up that middle term then as negative 6x plus 10x. Factoring by grouping, pulling a 2x out of that first group gives me 2x minus 3. Plus pulling a 5 out of the second group also gives 2x minus 3. And we have the common binomial 2x minus 3. Factoring that out gives me 2x plus 5. So that goes in the denominator here. All right, phew, factoring's the longest part of these problems. But I think we got it. Let's see here. 2x plus 5 divided by 2x plus 5. That's definitely no problem. I can divide those and just get 1. Now the x minus 3 and the 3 minus x. Those are almost the same, but not quite, right? Same two terms, 3 and x, but subtracted in the opposite order. Remember we talked about that right at the end of section 4.1. That form always divides to negative 1. So I'll go ahead and do that. All right, on the top, 3 times 1 times negative 1 makes a negative 3, and there's that x. And then on the bottom, 3 plus x. Addition, if you want to reverse those and write x plus 3, you certainly can. It's typical to write the x first, and reversing addition doesn't change anything. And then I also have that 2x minus 3. All right, let's take a look at a couple more. In example 3, this is multiplication, so I don't have to worry about taking the reciprocal of anything. But once again, I'm seeing quite a bit of factoring that I can do. So let's see here. Maybe I'll do my factoring off to the side this time. That to me looks like a difference of cubes again. A cubed minus b cubed. So I'll use that difference of cubes formula, which you don't have to memorize. That's always on your formula sheets. And in this case, the a will be 2x, cube root of that, and the b, the cube root of 27, is going to be 3. So I'm going to end up with a minus b, 2x minus 3. A squared is 4x squared, plus a times b would be 6x, and b squared would be 9. So all of that goes in the numerator of my first fraction. All right, the denominator, fortunately, is a lot simpler. The only thing I can see to do there would be to factor out an x. And that will leave me 6 minus x. Second fraction. X minus 6, that's prime. There's nothing I can do with that. I can put parentheses around it just to remind me that it's a multiplier now. And then the denominator, with 4 terms, I know I'm going to need to use grouping. So let me do that kind of off to the side again. I just find if I do my factoring in a separate area, it keeps my work organized and I don't get confused or try to start dividing things too early. All right, factoring out an x squared, 2x minus 3, plus I'll factor out a 5, which also gives us 2x minus 3. So we have 2x minus 3 times x squared plus 5. And that's the second denominator. All right, to me this is the fun part. We start getting to cross stuff off, right? 2x minus 3 divided by 2x minus 3. That is definitely 1. And here it is again. I've got subtraction, but in the reverse order. Same 2 terms, but in the reverse order. So I know that when I divide those divide to negative 1. All right, I end up with a negative 1 out here, and I can either put that in the front of the whole fraction, or I can distribute it through the top. For right now, I'm just going to leave it out front. On the bottom, I have x times x squared plus 5. Very typically, and I don't think I mentioned this before, but I probably should have, very typically when there is a factored form, we just leave it in our final answer. As you've been seeing, the factored forms are actually more useful to us. And so rather than undoing all the work we've done to get them factored, we usually leave them like that. So that would be a perfectly good answer. Or I could choose to distribute that negative sign through the numerator. I could have chosen to put the negative on the denominator, but again, it's much less common. So I'm going to leave it as those two. All right, one more example of multiplication, or actually division, I guess in this case. In number 4, we have a fraction divided by something that's not a fraction. When you have something that doesn't look like a fraction, you can always make it into a fraction just by putting a denominator of 1 on that. I'm going to need to think of it that way this time because of the division. That's going to require me to take the reciprocal of this. So I definitely needed to know that that 1 was down there. So I'll start by just rewriting this. And then I'll multiply by the reciprocal. So change to times and 1 over x squared minus 2x plus 1. To factor that numerator, I have a trinomial, but the leading coefficient is 1, so I can actually take the shortcut here. X squared is x times x. And then looking for a sum of negative 7, product of positive 6. Let's see, it looks like maybe negative 1 and negative 6 would do that. So x minus 1, x minus 6. Same idea on the bottom. Trinomial whose leading coefficient is 1. So right away I know I'm going to start with x times x. This time I need a sum of negative 3 and a product of negative 18. It's like 3 and 6. I'm going to have to make the 6 negative to get them to add up to a negative 3. So x plus 3, x minus 6. Second fraction, I've got a 1 on the top, and lots of practice with this trinomials with leading coefficients of 1. Got to be x times x. And this time I need a sum of negative 2 and a product of 1. I think we'll go with negative 1 and negative 1. Those add up to negative 2 while multiplying to positive 1. And there we go. We've got everything factored. All right, x minus 6 divided by x minus 6, that's 1. And x minus 1 divided by x minus 1, that's also 1. So on the top, I've just got 1 times 1 times 1, which is 1. And on the bottom, we've got x plus 3 times x minus 1, which again, I will leave in that form rather than trying to multiply out that denominator. Factored forms are usually more useful. All right, that brings us to the end of part A.